Hi guys, how are you after yesterday party? Hopefully you have some energy to talk about what we are going to present and have some time and energy for party tonight. I'm Vasily from Chainstack. I'm head of product and I'm going to talk about how we use Storj backend for our IPFS API implementation, especially for today's speech on IPFS Connect. First of all, a few words about what Chainstack is. Chainstack is basically a web-free infrastructure service provider. We run blockchain nodes for multiple networks, more than 25 different networks. You know, any popular networks that you can imagine: Ethereum, Polygon, Avalanche, Solana, Aptos, you name it. And we're running mainnet and testnets, and there is more than 50,000 nodes running around the globe for our customers, and we have almost 100,000 customers who are using our services. And besides nodes, which is our definitely a core business, we're also providing access to indexed blockchain data when fetch all transactions and receipts from blockchain and giving access to this data over GraphQL interface or SQL interface, or we can just share your dump with this database file. And using this indexed blockchain data, we also have such services as NFT API, wallet API, token API for those companies who need that. And last but not least, of course, we are providing access to distributed storage over IPFS API. And let's talk a bit about how we did that. But before I will jump into that, can you share me who knows that IPFS is not a storage? Okay, like at least half of you know that IPFS is not storage, which could be surprised for some newbies who came into this industry. But yes, IPFS is not a storage. IPFS is, for those who still don't know that, IPFS is just a way how to get access to your file. Yeah, how to find the file, how to find the object inside this decentralized or distributed storage system, and how to get information like when you can actually locate your file. And with that said, of course, you still need some storage solution behind your IPFS API. In much easiest way, of course, you can use local drives and just giving IPFS API to your local drives. But in that case, in case if you will lose this server, a virtual machine, you will lose your file. And definitely you would like to have your file distributed, redundant, for long storage retrieval time, and so on and so forth. That's the reason why any company looking how to store your files behind IPFS API. And in the simplest way how we did that, of course, in Chainstack, we have our user interface over web browser, and we have public API for RESTful API access. And behind this API implementation, user interface implementation, there is IPFS node, which is a binary, a software that's expose your IPFS API. And behind IPFS node, we have multiple Storj nodes. But you can use just one of them, but we have multiple because Chainstack service is a global distributed service. We have presence in Europe, in Americas, in Asia. That's the reason why we have Storj nodes, multiple Storj nodes. I will explain you a little bit more later how does architecture looks like. But before that, I would like to explain you why we choose Storj. And there is multiple benefits. I will share a little bit more information about pricing part because I'm, as a head of product, of course, thinking how to make this service commercially viable. And first of all, when we did investigation, what price should be from Chainstack as a commercial entity to our users and customers for the access to a decentralized storage network, and we did a competitive analysis, and of course, you know that Infura, Pinata, Flick, Firebase provide IPFS access to your files, and they have their own pricing. So we find the most lucrative pricing for our customers. This should be for storing data and, of course, for bandwidth when you upload and download your data. And we found that like for storing data, it should be like 7 US cents for 1 GB per month, and for uploading and downloading data, it should be 5 US cents per GB per month. This is like most affordable, most cost efficient price across all competitors. When we find, end user price for our customers, we start looking, okay, what solution we can use to actually, be still commercially viable and have some margin on top of that. And we did investigation like on multiple solutions, of course, starting from decentralized storage service like Amazon Web Services or DigitalOcean or OVH, like European cloud provider, to find out like how much we should pay for those service in case if we still would like to have free replicas, of course, of our files, not just a single replica, and to store a file, to upload, download those files. We did simulation for multiple user scenarios and use cases. And we find out that in case if we will use centralized storage solution, like we basically can't make money out of the services. And we start looking on some other solution like Storj and different decentralized storage solutions like RVF, Swarm and such. And we find out that Storj is actually the most cost-efficient, affordable service that we can make business on. And only after that, when we made commercial decision, we start looking how technically do integration of Storj. And as you can see, like Storj is like sweet spot for any use case that you can use for your decentralized storage solution. That's the reason why we use Storj at first. But of course, there is multiple other benefits, like Storj is geo-distributed. They always store free replicas, and this is like the reason why your data should not be lost. And of course, it's encrypted by default. So, how does architecture of Storj and Chainstack service looks like? So, of course, we have a user interface and public API to actually expose something to our customers, to our users. And when user upload or like just do manipulation with some files over the Chainstack service, first of all, there is an Nginx server with authorization to make sure that exactly this user or customer should have access to this file. And we do authorization with our core backend, and after that we provide our own implementation of IPFS API. And first of all, what we're doing, we store file that's been uploaded from user in local fast S3 storage in order to have as low latency as possible, as much bandwidth speed while uploading your file. So first of all, we store this file on local hot S3 storage. Then we have a set of IPFS workers who actually put this file from S3 storage to IPFS node, which has a plugin for Storj backend. And this IPFS node slowly, or maybe not so slowly, uploading this file to Storj backend network, having free replicas and so on. When we did such experiments, we find out that it could take some time, and definitely this is not something that users should be experienced like in web browser or like using IPFS API over some Linux machine. And definitely having temporary storage with S3 access is something that's drastically increase user experience and reducing latency. And after that, when we put file to Storj network, we make sure, okay, this is like uploaded, IPFS worker did the job, and finally we make sure that this file could be pinned and stored for a long time. And when user accessing this file, like for downloading, we of course have Storj network at backend, and we'll like downloading this file from Storj network, but we also use hot cache storage on IPFS node when user accessing file very often, like we can give this file to user not from Storj network but from local storage for much faster access. This is how we did architecture. It works well. We tested in multiple scenarios, and latency is so good. So we really happy that we did such integration. That's overall architecture. Of course, there is multiple other technical challenges that I definitely would like to discuss with you in case if you have some questions, and we can discuss it later in those rooms that we have here. So basically that's the main part. However, I have really generous offer and proposal for all of you. Any IPFS Connect participants who have presence here can get access to Chainstack platform and services and get a grant for $1,000 to consume inside Chainstack console for multiple services. Of course, for IPFS API access, but besides IPFS API, as I said, like you can use those grant to get access to RPC endpoints for Ethereum, Polygon, Avalanche, Aptos, Solana, like you name it, any different networks, and with to have access to our NFT API, subgraphs API, or anything else. So please just scan this QR code, and behind this QR code you will find a link which will go you to Chainstack console with that promo code that you will find on the screen. That's the main part, and my final word to expand your mind while you're building your Web3 products is the following. True and false, soft and hard, upgrade and restart, bootstrap and setup. This is Touchstone, where the future is shown. Lumos. Thank you, guys. In case if you have some questions, I have a couple of minutes.
Actually, if you can just walk me through the data, we'll do the put, get all the way through. So when I upload a file, it's going to hit your infra in a colo on some type of what, NFS mount? You said it was like being cached, and it's not using IPFS or Storj. So you have a file system there, and then you have something running, correct? That.
Yeah. So yes, we first of all, when we did experiment how it will work, we use multiple scenarios. Okay, let's put file immediately to Storj network. Okay, let's put file to some S3 temporary storage. Okay, let's put file to some other distributed network file system. And we did different experiments where we find out that the best user experience we could have in case if we will use local nodes to actually get this file from the user as soon as possible with local NVMe drives in different data centers, like depending on where user is located. So we get this file from user, we store it to local hot storage, and we have our backend with IPFS, so-called IPFS worker that just pulls this data from our local storage to Storj network or over IPFS node. And we found that it takes some time. There could be some, retransmit, some errors, lost connection, and it takes some time. But we make sure that this file is being uploaded to Storj network, so we can double check that. We can try to fetch this file from Storj network from other nodes from different continents to make sure that this is accessible, and then we can remove this file from local hot storage and just kept it on Storj network. But when user downloading this file from basically Chainstack through IPFS API with Storj backend, we first of all check, okay, maybe that file has been downloaded recently, and then we doing some caching for this file because we already got this file from Storj network and put on local drive and got access to this file to a user. In case if it's not, okay, we download this file from Storj network. It usually takes a little bit longer time than having this file on local drive, but it's much faster than when you upload file to Storj network, because when you're uploading, it's like has additional encryption, making additional replicas to make sure that this file is actually stored on the network. But when you download file, it becomes much faster than uploading.
And where are the encryption keys held? So there's two encryption pathways. I mean, the file comes into your network. I apologize. I have not seen your front end or anything, so we'll have to look at it. But you're encrypting it one time before it hits IPFS, and then you're encrypting it again on Storj.
Yeah. Definitely. So you're right. That's when we go.
These are really quickly. These are public IPFS nodes, correct? That you're running.
No, this is not public IPFS.
These are private IPFS.
This is private IPFS nodes.
Okay.
Yeah. Yeah. Sorry, we have no time, but I see this on the screen. I definitely would like to speak with you right now in the room. Thank you.